Okay, friends, we're getting down to the nitty-gritty here. So, first part of acid-base stuff, I wanted to show just some basics with pH calculations, and there's some basic ideas. So, if you're looking to find the pH of a solution, what you're actually talking about is the hydrogen ion or hydronium H3O plus concentration in molarity. So I made a point to put this in molarity. So what you're doing is actually calculator work. So if you've got the molarity of the H plus concentration, all you're doing is punching in the calculator of the negative log of that concentration. The same thing for pOH. If you know the hydroxide ion concentration, you're literally just punching in the negative log of that concentration, the molarity of it. Okay. Conversely, if you have the pH and you want the concentration of the hydrogen ions or H3O plus, and you want to get that, and you've got the pH, all you're doing is taking 10 to the negative power of the pH, and you can get that number. The same thing with the pOH. If you want the hydroxide ion concentration, 10 to the negative pOH will give you that molarity. And what you can do is go back and forth and saying, hey, these are 14-point scales. If I've got the pH, 14 minus the pH will give me the pOH. And if I've got the pOH, 14 minus that number will give me the pH. If you've got one number, you have the other number. You can flip back and forth all the time. So I put up a PDF document online, and I'm not going to go through all the numbers because a lot of it is just calculator work, but I did feel like I owed you a little bit of an example. So if you've got, for instance, 0.0027 molar concentration of H plus or H3O plus, it's the same thing. Put in your calculator negative log 0.0027, and that will give you the pH of that solution. And you're saying, hey, that number is 2.57. And if you remember, pH is in a 14-point scale, 7 is neutral, above 7 is basic, anything under 7 is acidic. This is a pretty acidic solution. It's not the strongest acid or not the most concentrated acid in the world. I don't know if I'd want to pour it on myself, though. Oh, well, if you want to get the pOH, 14 minus the pH gives me the pOH, and it's saying, oh, there's not a lot of hydroxide ion in that solution. Just giving you a little bit more information. Cool. Well, another example. Here's a solution that is 6.2 times 10 to the minus fifth. And if you want to see that as a decimal, 1, 2, 3, 4, 5. Do it scientific notation, it'll save you some trouble. So if you take the negative log of 6.2 times 10 to the minus fifth, that gives you a pOH of 4.2. Again, on a 14-point scale, that's telling you it's pretty basic. We don't talk pOH a lot, and you're like, that's a little bit confusing. Can I put that in pH? Because I'm used to thinking of acids and bases on a 14-point pH scale. Absolutely. 14 minus the pOH gives me pH. Oh, that's a pH of 9.8. So 7 being neutral, yeah, that's basic. It's definitely above 7. It's not the most basic thing in the world, but, you know, again, it's you know, definitely above that neutral point of 7. So a couple of other things here. Let's show you the example of going from the hydrogen ion concentration to pH, or from pH to hydrogen ion concentration. So let's say you've got a pH of 3.3, and you want to get to H plus. And again, that's the same thing as H3O plus. They are equivalent. So you remember, oh, that's 10 to the negative pH. So when you put that in your calculator, you want to go 10 to the negative 3.3 power. So when you do that, you get a number that's 5.0, or really close to it. I had to do a little bit of rounding. And again, it's molarity. So that's going to tell you the proton, the H plus concentration in that solution is 5.0 times 10 to the minus 4th. So pretty concentrated. It's not a pH of 1 or 1.5, where it's a whole lot of acid, but again, relatively acidic. Same thing if you wanted to do pOH and you wanted to see, hey, how much hydroxide I got. So if you've got a pOH, that's worth 5.7. That's not going to be super basic because 7's neutral. Okay, well, 10 to the negative 5.7 is going to give you your hydroxide ion concentration. That's 2.0 times 10 to the minus 6 molar your OH minus concentration. So again, these are calculator problems. Just showing you how to punch them in. I've got one last concept I want to show you, how if you're given one piece of information, you can work all of your way through. Okay? Back in a flash.